Hello, my name is Bradley Alisea. I'm from the Open Worm Foundation, and I'm going to talk today about game theory of developmental processes. And this is the application of game theoretic models to biological development and its associated processes. So the big idea here is to take the things like developmental variation, morphogenesis, and learning/adaptation and try to better understand them using game theoretic models. So if we consider a group of agents taking the form of cells, morphogens, or gene products, we can assume that they emit a set of discrete states. And so a developmental game is the strategic interaction of these states. So to get there, we need to create a special type of agent called an ontogenetic agent. They don't act like rational agents as in game theory. They act as natural agents that don't really have cognition. We also need to consider biological intentionality. So again, the ontogenetic agents don't generate rational decisions or goal-directed behavior necessarily, but they do things like move collectively and other types of behaviors such as that. So we create a couple of classes of games. One are zero-player games. This includes Conway's Game of Life and point processes, special types of point processes. We consider one-player games like Developmental Minesweeper and Games Against Nature, and then multiplayer and two-player games such as Noughts and Crosses, otherwise known as tic-tac-toe. This creates a first-mover model for embryogenesis and connectome assembly. So on the bottom you see that we can model the spatial organization of embryos, and on the left and in the center we have a model for connectome assembly. And this is a very, we can model this using a complex, we can come up with a number of complex strategies and evaluate them. So if you're interested in learning more, and there's much more in the preprint, you can scan the QR code on the left and you could read all about it in the preprint. Thank you for your time.